Well, now that we're done with the Desmos, I walked around for the kids who were in class and kind of saw that we're still a little shaky on the purple note card. That's what that whole Desmos was about, was seeing if you could tell how things affect with the purple note card and explaining things. We'll get better at it. So what we got here is our basic, generic, plain old exponential function with all the sprinkles added to it. So here's your base in that case, but you got an a value, an h value, and a k value. And we're not even going to do all 4 steps to the purple note card. We're just going to do the first 2 steps, because the other ones, the dilating and stuff like that, it's so hard to see what happens to an exponential graph. So one of the questions on the Desmos asked you, like, where was the horizontal asymptote every time? Well, it's always going to be at y equals k, because what does k do, guys? What does k do to that thing? Translates up or down in this case. So let's rock and roll with all of this. So this guy right here, he is what? Exponential growth or exponential decay? Let Megan Trainor help you. Exponential growth. It's all about that base, and that base is bigger than 1. So that's our first 2 reasons right here. Exponential growth, the base is bigger than 1. And now what we have to do, there's one more little thing before we get started that is a lifesaver. And I got to take it back to maybe 2018. I'm pretty sure it was not in 2019, but I could be wrong. I don't follow these songs very closely, but we need another goofy little song to help us out. It's not about Megan Trainor this time. But what we want, before we do the purple note card on this to see what this graph looks like, is let's go right here and we make ourselves what I call the, you ready for this? It was the most annoying song of probably 2018. I'm guessing that's when it came out. Do you know what song that is? Baby Sketch. Oh, Shark, excuse me. When did that come out? Baby Shark? I don't know. But we're going to make a baby sketch of this guy. Would you believe that exponential growth, boom, looks like that normally? That is a normal exponential growth. And if you make the baby sketch, that will save your life, as you will see as we come up. So this is what it looks like if it was plain Jane vanilla. But he's not plain Jane vanilla. They added and subtracted, and sometimes will multiply some stuff. So the first thing is if they reflect over the x-axis. And my friends, it's about the a value. The a value is the number in front of the base. If he is negative, would you believe that the number in front of the base is an uno in this case? It's just a 1 right there. You don't see him. If he is negative, this guy gets reflected over the x-axis. Does this guy get reflected over the x-axis? No, it does not, so we'll do. But let's pretend he did. If I pretend that he did, would you believe that this graph right here, boom, does one of those right there? It would totally look like that. But that's not happening, so I'm not going to put that on my baby sketch in that case. Then the translation part, we rock and roll that. Translated where? 3 units left, because it's opposite of this guy. And where else? 5 down. Questions about those, right? If it gets reflected or not. But then we've got to do where the critical point was. So don't draw this, but if we were doing a parabola, like old school parabola, would you believe that the parent parabola has a critical point at 0, 0 in that case? Well, that's not the idea for the exponential guy. His critical point is at 0, 1. So quite possibly, guys, there are 2 things that could happen to 0, 1. Because you watch here, 0, 1 is like right there as opposed to 0, 0. And would you believe if you reflect it over the x-axis, that 0, 1, bada boom, moves down here. It has somewhere to go because 0, 0 never moved anywhere when you reflected him over the x-axis because he's on the x-axis. So it depends on what we've got going on. However many things that happen in our 2 steps for our purple note card, that's how many things we got to do to 0, 1. So since this guy did not get reflected over the x-axis, 0, 1 is still going to stay at 0, 1. But now we got to translate him 3 units left and, 3 units left and 5 units down. And you just do arithmetic on this. You take the 0, which is where he originally started, and add -3 to it. Where would that turn out to be? -3. And you take the 1 and you add -5. Or if you want to think subtract 5, whatever your brain is more comfortable with. Where would 1 move to if you moved him 5 units down? negative 4. So the critical point of 0, 1, since it's been moved 3 units left and 5 units down, will now be at negative 3, negative 4. But before we even sketch that and put that on our graph, we need to know where the horizontal asymptote is. He is the secret to our success. He will always be at y equals k. So where is our horizontal asymptote at? Y equals negative 5. This thing has been shifted 5 units down in that case. So that's how we'll start. We will start by drawing the horizontal asymptote. Make him as a dashed line. And put that little HA, y equals negative 5. Now, if I'm going too fast for you, you can always pause the video, but get that guy drawn in there. Now that we got the asymptote there, let's go plot our critical point of negative 3, 1, 2, 3, negative 4. And you don't even need to label him. Since we are on a grid, you know, it's like, and we're counting by ones, we know where negative 3, negative 4 is. If it was a freehand sketch, you'd have to put that ordered pair there. But then back to our baby sketch, it magically moved over here, sorry, but my baby sketch, we're going to make him look just like this. This is an exponential growth, so it's going to go bada boom. Pretty basic in that case. We're just doing a sketch. We don't need any other points of this guy, so just a sketch in that case. Do the domain and the range for me, and then check with mine. Domain from left to right, still negative infinity to positive infinity. We usually call it all reals. But the range, how low does this go, guys? How low? To negative 5, but can it touch it? It's not included because there's an asymptote there, and then right here, all the way up to infinity. And this was what I was looking at that very last question on the Desmos for. It's how I know we don't really get that purple note card thing yet. It was the last question on Desmos. Please describe what has happened from this one to this one. That is the sentence that they pull out in college algebra all the time. That's why we keep practicing the sentence. So we got to say the graph of, and then we got to list the parent function, and I need your help. Who is the parent function? If you strip away all the flavorings, all the chocolate, all the sprinkles from this ice cream and strip it down to vanilla, who is the parent function of this guy? It'll be y equals, what do you think? Strip away everything. It's got to be exponential. The x has to still be up in the exponent, but get rid of all of the crap that happened to it. What do you think? Y equals 2 to the x. Right? Y equals 2 to the x has been. The graph of y equals 2 to the x has been. You get rid of all the translations, all the dilations, all the reflections, and my friends, you're left with y equals base to the x. It's all about that base. You know, the base was 2 in this guy. So that's as plain Jane as that graph could get if we stripped him down to vanilla. But they did some fancy stuff to it. They shifted it 3 units left and 5 units down, so it looks a little fancier in that case. So it's y equals base to the x is the parent function every time. It's all about that base. Coolio with this guy. It's a pretty simple day today, right? It's just doing the purple note card again, which, yes, you can use your purple note card, but we're only doing 2 steps. So let's do it again. Megan Trainor needs to help us. Who is the base of this exponential function, my friends? 2/5. Boom, which means that is exponential decay. And we can explain by saying in English that the base is between 0 and 1, but we'll write it in math like so. And this is where we need to go to the baby sketch, right? The baby sketch is going to help us. Let's sketch a basic exponential decay. You help me. Is it the blue one or is it the red one right here? Which one is the exponential decay? Red one, right? So let's make a little sketch of that red guy. This is what he looks like when we strip him down to vanilla. This is the basic exponential decay. Cool? Well, all right, it's time. Step 1, has this guy been reflected over the x-axis? What do you think? Yes. So we'll write it like so. And you need your eyes to help you. Go to the baby sketch and reflect that over the x-axis. Do one of these. Do you feel comfortable that that blue thing is what that would look like if you reflect him over the x-axis? Trust me, that is the most important thing. I've been doing this a long time, and we will never get the sketch wrong if we do that one move. Translate. Where has he been translated? And now, however many things happen here, that's what has to happen to 0, 1. 0, 1 is normally right here. Where would he move to if we reflect him over the x-axis? It would go right here. Where is that? 0, negative 1 is what happens in phase 1. This guy got reflected over the x-axis. And now, this is the point, if my pen would work, sorry, that gets translated 4 units right and 2 units up. So we have to do the translation arithmetic to this guy, right, 0, 1. So let's add 4 to this, and that would go to 4. And then add 2 to this, and where would that put us at? At 1. Negative 1 plus 2 more is 1. Are we okay with that? So that thing had 2 things happen to it. It got reflected over the x-axis, boom, and then it got translated. And remember, that didn't happen back to the parabola because the parabola's critical point was at 0, 0. So that's new. And then the horizontal asymptote will always be at y equals k. So it'll be at y equals 2. Start there. That's how you start your graph. Graph the horizontal asymptote. Don't forget to put the little HA, y equals 2. And if you need to pause, go ahead. Now let's plot the critical point. The critical point is now at 4, 1. So 1, 2, 3, 4, 1. Whoa, whoa, whoa. That is underneath the asymptote. Is that supposed to happen? What do you guys think? Why did that happen? Because it got reflected over the old x-axis. So now everything's down here. And now the question is, how should this guy go? Should it go like this, or should it go like this? Sorry, I missed a little bit there. But which one do you think, the purple one or the red one? Purple or red? What do you think? Would you believe that it's kind of tough to tell if you were just guessing? But if you go back to the baby sketch will show you which one it's supposed to look like. Is it supposed to look like the purple one or the red one? It's supposed to look like this red one right here, just like this. Sorry, I thought I had purple and purple not matching up there, but still, it's supposed to look like this guy. So we'll graph the red guy and do our domain and our range. Yeah. It has been brought up that my baby sketch was wrong. We originally had the correct baby sketch, which should look like this, and now shouldn't the baby sketch look like that? So to go back to where we were, we had a horizontal asymptote at y equals 2 up here, and our point of 4, 1, it should go like this, correct? Thank you for pointing that out. New slideshow this year. Sometimes I go a little too fast and make mistakes, so I appreciate that being pointed out. So let me make a better sketch of this while you guys do the domain, range, and see if you can write your sentence. All right, I got a better picture of it now. What's the range, though? How low does this guy go? Negative infinity, and then the height goes all the way up to our asymptote of 2 in that case. And it's not included because you can't touch it. Then let's strip this guy down to the parent function. It's y equals base to the x, right? So this would be y equals what to the x? 2/5. All right, y equals 2/5. The graph of y equals 2/5 to the x has been, so when I go to the next slide, it's going to have the wrong picture again. So sorry about that, but it does have the right sentence. The graph of y equals 2/5 to the x has been reflected over the x-axis and translated 4 units right and 2 units up. So pay no attention to that because I made another mistake. But this is the right sentence. All right. Let's keep on keeping on. This guy, woo, exponential growth or exponential decay? You decide. I'm going to pause. You decide, and then we'll come. It's a good question if it's growth or decay because it depends on who the base is. What number is the base in this problem? Is it 5 or is it negative 5? What do you think? It has to be 5 because we learned last class period, which was still new to us, that if it's exponential, the base is either bigger than 1 or between 0 and 1. Right? So you can't have a negative base. Guess what this thing does to the base of 5, though? It does what? Reflects it over the x-axis. So you strip all that stuff away. This is definitely an exponential growth because the base is bigger than 1. Let's make a baby sketch. Meow, meow. So exponential growth like so. And then we'll do our 2 steps. We have already discussed that it has been reflected over the x-axis. I think that we should go to our baby sketch and do that. So that's nice. And then he has been translated just 2 units right, nowhere up or down. Please move the point 0, 1. 2 things happen to this, so 2 things need to happen to 0, 1. However many we fill out, that's how many things happen to it. The cool thing is, if it gets reflected over the x-axis, 0, 1 always goes to the same spot. It always goes to 0, negative 1. That would be, if that happens, because it's the only one place it can move, to right there. But then you do the addition to this. So 2, negative 1. How do you feel about figuring out where that critical point has moved to? And then I will make the most honest mistake ever. I'm going to get the asymptote wrong, see if you can tell what's wrong about it. That is not the correct horizontal asymptote. What is it supposed to be? Y equals 0. But where did I get the negative 1 from? Where this thing like finally ended up at, you know. So just watch out. It's not a negative 1. It's at a 0. So let's graph him. Get my asymptote first. Boom. And plot the critical point and make a sketch. Let the baby sketch help you. Again, pause if you need to. We'll plot 2, negative 1. That's under the asymptote again, which is supposed to happen because it got reflected over the x-axis. And then use your baby sketch for a guide, and I have the correct baby sketch this time. So it's supposed to look just like this guy, but go through that critical point. And then the domain, the range, and the sentence. Cool. So domain, all reals. The range, it went down from negative infinity all the way up to 0. And then if you strip this guy down, would you believe that the parent function is y equals 5 to the x, right? So the graph of y equals 5 to the x has been blah, whatever your 2 steps say, reflected over the x-axis and translated 2 units up. Awesome. Now for us to come up with our own formulas. So it says if this much money is invested at an 8% interest compounded annually, boom. That's the one word you really need to realize. Which formula do you need? This is annual interest. So you could actually use this formula right here. But what would go in for K if it was compounded 1 time a year? You just put a 1 in that situation. And it would just turn out to be the exact same formula. You'd have R over 1, which is just plain old R. You'd have 1 times T, which is just plain times T. So I need to do realize what this number is. That's the trick. Is this the principal amount, or is it the amount that we got after the fact? Principal, the amount we started with, or the amount after the fact, the S value. What is that? That's the principal. So start with the S equals, though, and then put the 8,800 times 1 plus the rate as a decimal, which is 0.08, which I already just add those together. To the time power, how much time? Doesn't it just say X years? Right? Is that right? That's all they want. Then they just wanted the formula. Right? There's nothing we can do. We've got 2 different variables missing. We've got X and we've got S. So that's all they want. Oh, I must have cut that off. My bad. Oh, that's part A. Duh. I didn't cut it off. It's actually the question in part A. 8 years. My bad. So 8 years. Thanks. Somebody's got a case of the Mondays. So I'll punch it in. This you can punch from left to right. How come? What's in the parentheses is nothing nasty. It's just one term in there. So 8,800 times 1.08 to the 8th power. 16,288.19 dollar bills. I don't know why they use such large interest rates. I think they're trying to tempt you into investing, because it's like, dude, I totally doubled my money in 8 years' time, and you just let it sit there. There is no place in the world that's going to give you an 8% interest rate. Interest rates are in the 2s, So investing is good, but Regular old banks, way smaller interest rates, you know. It's like makes you feel, it's like, dude, invest my money is the best thing I can do, which it's not a bad idea. It just won't grow nearly as fast as these problems will. So 30 years, do it all over again. You could do this if you really wanted to. If you hit second entry, it brings that entire entry back up again, and you could just scroll back over this 8 and put a 30 in its place, and it would give you that answer. 88,551.38 cents. Or you could type the whole thing back in again, whatever you wanted to do. Cool. Pretty simple day. E and C. Next guy, compounded quarterly. So 10,000 is my principal, 12% interest. Wow, that is ridiculously high. We will make some serious money then. So that would mean the amount would equal, I'll use A, sorry, it should be S. Back it up, Chuck. S equals principal of 10 G's times 1 plus my rate as a decimal over how many times I compounded. What does quarterly mean again? How many times? 4. To the 4 times 10. That's all I'm using here. Right? K is the number of times compounded. T is your time in years. R is your rate as a decimal. Since there was a periodic, it wasn't just every year. That's why I'm using this formula. Then I slice him out and put a 40 right there. Some of you can do that mentally. That's up to you, you know. And then we got to punch this guy in according to the order of operations because he'd be difficult to punch in the other way. 12% divided by 4 plus 1 to the 40th. And check it out. This tells you what's going to happen to your money. This number means it's going to get more than tripled in this situation. In this 10-year time, this number means, hey, man, it's going to be 3.26 blah, 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 blah times as much times 10,000. Hot dogs. Awesome. 32,620.38. Guys, if banks were that nice, I mean, just think about that. I could put 10 grand in the bank when I started teaching. It's been 12 years since I started teaching, you know. It's like to make $20,000 by doing nothing. Wouldn't that just be awesome? But 12% interest just doesn't happen, you know. It's like in the 2% interest. Sweet if it did, though. Let's do 6A. 10,000 compounded annually, so that's the simple formula. 10,000 times, make your percent a decimal and add 1 to it. And 18 years, this is your typical, you were born and your parents put away some money for you for college, you know, and luckily they put away 10 grand for you. How much would it be worth 18 years later, right? Because now you're in college. So you punch that in. 1.06 to the 18th. 6% is at least a reasonable amount. A lot of the questions will ask you how much interest did you make. How much interest did you make if there's 28,000 plus later? How much? 18,000 plus, right? You know, because 10,000 was your principal. That was your own money. You got a free $18,543 just by letting it sit there. How would this change if it was invested continuously? That's the PERT formula. So your amount will equal your principal. Principal is still 10,000 times E to the rate as a decimal, 0.06. Not 1.06, it's just 0.06 times time, and this was 18 years. So I'm going to punch 0.06 times 18 in first, figure out whatever the heck that is. That's the 1.08 power. Y'all cool with what I did there? Then I just punch that guy in from left to right, 10,000 times E to the 1.08. And I got 29,446.80. So now let's compare them, because that's what they ask. How does this compare to the same amount? So You were given, let's say your parents were giving you two options when you were born. It's like, hey, put it into this account, which compounds it annually at 6%, or it compounds it continuously. Which one's the right choice? Obviously, continuously. How much more did they make? So I'm going to take this bad boy and subtract away the 28,543.39. And didn't they make $903.41 more? Right? So that's what we'd say. It's like continuous, if I spell it right. I still didn't spell it right. Continuous. Compounding gives us $903.41 more over the same period. Same rate, same period, right? We made an extra, basically $900 just because of how many times they compounded it. Like every second of the day, it got compounded. I wish we wouldn't have done continuously. I wish we would have done just like monthly or something just to see the difference. Because the monthly situation happens all the time. Usually, that's the way banks roll. Every month, they compound interest on you. Cool. Boom. What lump sum must be invested? Wait a minute. What number is this? Line 7? Okay. What lump sum must be invested at 10% compounded monthly for the investment to grow to $65,000 in 8 years? What is $65,000? Is it the amount or is it the principal? The amount. So $65,000 will equal the principal. That's your lump sum. You don't know that, guy. And this is monthly compounded. So times 1 plus my rate. They told me that is 10%. That's an awesome percent. Compounded monthly. So that's how many? 12 to the 12 times 8 power. Because it's, again, number of times compounded times years. 12 times 8 is 96. Is that right? So I need to solve for P. We'll make it real simple. Isn't P times all of this crap right here? How do you get rid of times all of that? You divide by all of that. P equals 65,000 over 1 plus 0.10 over 12 to the 96th power. That's how I got P all by itself. Now, to punch that in, that's a whole other story. Let's punch this stuff in first. This is the nasty part. Let's do 0.10 divided by 12, hit equals, add 1 to it, hit equals, and raise it to the 96th power. All I did was figure all this stuff out right here as a nasty number. I will not round it, though. What I need to do is take 65,000 and divide by that number. So 65,000 divided by my previous answer is all I will do. And how much money should we put in? $29,303.36. And the question that my math lab might give you, is that enough? Because didn't we round this to 36 cents? So what you have to do is substitute it back in and see if you actually get $65,000 back. Because if you got $64,999.99, you really didn't get $65,000. So we might have to round this up to 37 cents. So what I need to do is take this number, not this number. We can't use this because that's not the answer we're putting in. We're thinking this is our answer. Let's take 29,000. Well, wait a minute. Clear out. We're putting that guy back in for P, right, into our original. So we want to see if 29,303.36 times 1 plus 0.10 over 12 to the 96th power is really 65,000. So you got to punch it all back in again. 0.10 divided by 12 plus 1 to the 96th power times 29,303.36. Boom. Did I get $65,000 back. Not quite. So instead of 36 cents, what do you got to do? Round it up to 37 cents. Now, sometimes that number will work, you know, because of just the way it is. So it's not like you always say, I'll always round up, I'll always round up. But quite honestly, if this was a real life situation and this is what you wanted, they said, hey, man, how much would you have to start with? You must invest $29,303.37 for that to happen. What would normal people invest? $30,000. You know, they'd round it up to the nearest thousand. You know, it's like, I'll just put $30,000 in the bank, and that'll guarantee me I'll get what I want by that 8-year period. You know what I'm saying? One more. Pa-pa. Why don't you set that up for me? So we want to have $30,000 compounded 12 times a year because it says monthly for 18 years. So a formula should have looked like this. To get P all by itself, I divided by this whole hunk of a number. Now I'll punch that in first. 0.10 divided by 12. Add 1 to it. Raise it to the 216th power because that's what the 12 times 18 turned out to be. And now I'll take 30,000 divided by that number. So I'll just use the previous answer. And $4,996.09. We need to check to see if that works. So I will start all over and take 0.10 divided by 12, add 1 to it. Come on, baby. Not 11. Raise it to the 200 and whatever power. And then take it times that number. 4996.09. I didn't get $30,000, so 10 cents. Right? So that's what we'd have to do. Quite honestly, though, what would you invest in real life? $5,000. Yes?